Algebra 2 Notes 1.4 Part 2, Solving Linear Equations and Word Problems. Go ahead and get started with the warm-ups. We are on page 5. Go ahead and pause the video as you work through the warm-ups. All right, go ahead and check the warm-up problems. For the first one, you needed to distribute and then add some like terms. Finally, once you get x's on one side, we can add the 2x to get 8x, add the 6 to get 3, but we end up with that fraction. So x equals 3/8. For part B, this is those literal equations. We are solving for y. So we can first subtract the 1/2 x to the other side. From there, we have -1/4 y equals all that. So to get y by itself, remember you can multiply by that reciprocal. So the reciprocal, and then we want it to turn positive. So we're going to multiply both sides by -4. Okay, so then when you do that, we're actually distributing that -4 through to everything. So -4 times 1/4 would just be 1. Then -4 times -2 would be 8. And finally, -4 times -1/2 would be positive 2x. And then I just rewrote it so that it's in like slope-intercept form. Y equals 2x plus 8. All right, so today's lesson involves a little bit more fractions within the problem, not just in the answer, and then some word problems. So let's go ahead and get started on these two. For this first one, if you notice that the denominators are both 3, and then over 2, 2 would be over 1, 7 would be over 1. So to get rid of those 3's, what you can do is take the entire problem times 3. All right, so once we do that, then we can distribute that 3 to all these items. So 3 times x over 3 would just be x. 3 times -2 would be -6. And then leave your equals. 3 times 5/3 x, the 3's cancel, so it's just 5x. And then 3 times 7, 21. All right, then from there, we want to get x by itself. So this makes it a lot easier problem if you do that first little step by getting rid of the denominators. It's called clearing the denominators. So from there, get x's on one side and variables on, or numbers on the other. So we can subtract the x to get 4x, then we can subtract the 21 to get -27. So we have -27 equals 4x, and then finally divide by 4. So your answer would be x equals -27 over 4. All right, for number 2, this one's a little bit trickier. We need to figure out what should we multiply this whole problem by to get rid of all 3 of the denominators at the same time. So right now we have a denominator of 3, 2, and 4. So think about what can we multiply at all times to get rid of those denominators. All right, so the least common multiple of 2, 3, and 4 could be 12. Okay, so 12 will cancel the 3 out, the 2 out, and the 4 out. So again, just like the first one, we want to distribute that 12 to everything. So 12 times 2/3 y, 12 times 1/2. I'm just going to take it times the 1/2 and I'll distribute it in a minute. And then 12 times, 12 times that last fraction. There we go. Okay, so when we do 12 times 2/3 y, what happens? You can multiply the top, so think of that as like 12 over 1. Then that becomes like 24 over 3. Or you can simplify and divide 12 divided by 3 as 4, and then take 4 times 2. So either one, 24 over 3, or 4 times 2 is 8. So we go 8y plus, and then 12 times half. Half of 12 is 6, but we still have that y minus 3 in parentheses. And then equals, over here the 12 and the 4 will cancel to just be a 3 on top. Now we still need to leave that y plus 1 in parentheses over there. All right, so the good thing about that is we have no more denominators to work with, and now we can just solve the problem. So why don't you guys pause the video and then go ahead and solve for y. All right, so after I distribute the 6 and distribute the 3, here's what I've got. If I want to simplify that left side, I can get 14y minus 18 equals 3y plus 3. From there, I can move the y's to one side, so subtract 3y. And then at the same time, I can add that 18 to get 21. 18 plus 3 is 21. Finally, I can divide and get y equals 21 over 11. All right, let's go to the next page, page 6. So for these problems, we're trying to set up and solve an equation. It says find 4 consecutive integers whose sum is 50. So consecutive integers, an example of those would be like 1, 2, 3, 4, or 7, 8, 9, 10. So any set of 4 numbers that are right in a row. So one way we can solve this is to call that first integer x, and then add it to the next one. So we have to go one more than x. The second one would be called x plus 1. And then the third one would be called x plus 2. And then the fourth one would be called x plus 3. So that this last number here, if we look at our example 4, was 3 more than the first number. And then we want it to equal 50. So see if you can find what 4 consecutive integers whose sum is 50 is. So not only do we want what x is, I want all 4 numbers. So go ahead and pause the video and see if you can finish that problem up. All right, so if you add up all the x's, we have 4x plus 1 plus 2 plus 3 would be 6 equals 50. Then we can subtract the 6 and finally divide by 4. 4x equals 44, x equals 11. So 11 was what your x was, but what are consecutive integers? They would be 11, 12, 13, and 14. Okay, you can double check, do those 4 numbers in fact add up to be 50? Yep, they do. All right, let's try number 4. Now this one, for even integers, we have to do something slightly different. We can still start with our first integer being x, but then to find the next one that's an even number. So imagine if x were 2 and the next number were 4. The second number I need to call it x plus 2. Okay, and then equal to 46. So this is your second number. This is your first number. So no matter what I plug in there, if x is like 6, then this would be 6 plus 2, 8. So they're even integers that go right in order. All right, so if we solve that, we get 2x plus 2 equals 46. 2x equals 44. X equals 22. So again, we don't just want to know what is x, we want the 2 numbers, 22 and 24. So you can either just use common sense to figure out that second number there, or you can actually plug it back in. If x is 22, then the next integer would be x plus 2, so 22 plus 2, and that's how we get 24. All right, next one. Find 3 consecutive odd integers such that the sum of the largest and twice the smallest is 25. All right, this one does not give you the total of all 3 numbers like the other ones did. So what I'm going to do is just kind of write over here what I'm letting all the numbers be. and then I'll try to write some formulas. So this time I want odd integers. It seems like we should do this different, but we actually do exactly the same as even. So if we imagine our first number is like a 3, how would I get this number to be a 5? We can just take that original number, we got x, and add 2 to it. So that next number would be x plus 2. And then again, imagine if that's 3, I want this one 2 odd numbers higher. So this would be x plus 4. So if that's 3 plus 4, that would be 5 and then 7. All right, so it's giving us a couple equations here. It says the sum of the largest and twice the smallest is 25. So twice the smallest, we're going to take 2 times the smallest, x, and then the sum of the largest. Sum of the largest. So the largest would have been x plus 4. So the sum of the largest and twice the smallest is 25. I wrote that backwards. If you want to write it the way the equation's written, it's the largest plus twice the smallest is equal to 25. All right, so go ahead and solve that and then find your 3 numbers. Go ahead and pause the video, see if you can finish that one up. If you have the hang of it, try number 6. We had one similar to this on our assignment yesterday, and I think I set it up for you guys in class. So see if you can figure out number 6. All right, if you finish up number 5, you should have gotten x to be 7, and then it wants all the odd integers. So if we plug that back in, that first one would be 7. This one's 7 plus 2 would be 9. And then that last one, 7 plus 4, would be 11. So then your numbers were 7, 9, and 11. Okay, if you want to double check the formula here, twice the smallest, so that'd be 14, plus the largest, 11, is 25. Yep. All right, this one, last one here, go ahead and sketch out a rectangle, just so you can visualize it. It says the width of a rectangle is 8 centimeters less than the length. So this time it's giving us the length, and then the width is x minus 8. And then it's giving us the perimeter. So remember that not only is this bottom side x, this top side is also x. And then same thing on the right side there. That's going to also be x minus 8. All right, so what we want to do is add up all these sides. So we're going to have first side plus second side plus third side plus fourth side, all is equal to 42. So that's how we do that perimeter. Just add up all the sides and set it equal to the total. So go ahead and fill in all the sides, x minus 8, x minus 8, and x. See if we can get it to work out. Go ahead and pause the video while you fix this problem, and then we want the answer in dimensions. So think like an 8 by 10 photo. How would I write the dimensions of this rectangle? All right, if you fill in all the sides, so we have x minus 8, plus x minus 8 equals 42. And add like terms, x plus x plus x plus x. We have 4x minus 16 equals 42. And then just do the algebra there, add the 16 divided by 4, and we get x to be 14.5. So what are the dimensions of our rectangle? So that's the bigger side. The shorter side would be whatever 14.5 minus 8 is. So your dimensions would be 6.5 centimeters by 14.5 centimeters. All right, for your assignment here, if you turn to the next page there, your assignment is page 7 through 9 in your packet. So you don't need to use the textbook this time or the online work materials. It is right there in your packet. Okay, so the first couple problems you're just trying to solve, and then we'll get to some of the word problems there. All right, email Mrs. Smoots if you have any questions, and have a great day. Bye.